Hello everyone. Today we are going to see a question on gravitational force. The question is, what happens to the gravitational force if one mass is doubled, the other tripled, and the distance between them is halved? So before solving the question, I'd like to put some light on the law of gravitation. Law of gravitation. So the force due to gravitation, I am representing it by F. Okay, F is a gravitational force. F is gravitational force. The gravitational force can exist between any two masses. Gravitational force can exist between any two masses. If two masses are there, then surely gravitational force is acting between them. So here I have drawn two masses, m1 and m2, separated by distance d. One more important point about the law of gravitation is that it is valid only for point masses. That is, the size of the masses compared to the distance is very small. When I compare the distance between the masses to the size of the masses should be negligibly small, then the law of gravitation is valid. So m1 and m2, let them take it as point masses separated by distance d. And this force of gravitation is always attractive force. The law of gravitation states that the force of gravity is always attractive force. So the force of gravity because of masses. So according to the law of gravitation, the gravitational force is proportional to product of masses. Okay, the gravitational force acting between these two masses is proportional to product of the masses. So m1 into m2, and this gravitational force is inversely proportional to the distance between them. So inversely proportional to the distance between them, 1 by d square. By combining 1 and 2, we can write F is proportional to m1 m2 by d square. m1 m2 by d square. And in order to remove the proportionality, F is equal to g m1 m2 by d square. Clear? So this force is gravitational force. Okay, gravitational force is equal to g m1 m2 by d square, where g is universal gravitational constant. And its value is equal to 6.67 into 10 power minus 11 Newton meter square by kg square. Okay. So Newton meter square by kg square is unit of G. Capital G. Universal gravitational constant. So what is the force acting between the two masses given to us? Let's see that. So from the law of gravitation, F is equal to G m1 m2 by d square. Correct? Now if you see our question, in this question, what happened? If one mass is doubled, say m1 is doubled, if initial mass is m, now when it gets doubled, now the mass is 2m1. And what happened to the other mass? The other tripled. The third mass has been tripled. So initially m2, now 3 times of m2. And what happened to the distance? The distance between them is half. Okay, is half. That means now the distance is d by 2. Now the distance is d by 2. Whatever I have written here with black ink, they are the initial condition, and whatever I have written in red ink, this is the condition given. Okay, new condition given in the question. So let us find out what happens to the net force. Let us find out what happens to the net force. So from the law of gravitation, the new force, I am writing it as F new force is equal to G is universal gravitational constant, not going to change. M1 mass has become twice 2m1. M2, the mass has become three times of M2. And what happened to the distance? Half. That means d by 2 whole square. So this we have written according to the law of gravitation. Let's see what happens. Okay. So this is a 2 into 3, 6. 6g m1 m2 by d by 2 whole square. So this gives us a d square by 4. So d square by 4 goes to the numerator. We have 6 into 4 g m1 m2 by d square. What is 6 into 4? 6 into 4 is 24 g m1 m2 by d square, and I can write it as, what is g m1 m2 by d square? G m1 m2 by d square is initial force, is the initial force. So I can write this as 24 times of initial force. 24 times of initial force. So the new force which we have got by these conditions is equal to 24 times of the initial force. So we can say that the force has increased by 24 times. Okay, I hope it is clear. If you have any other doubts, please comment it. Thank you.